Hi, this is Mrs. Benke. In this screencast, we will be looking at the 5 main types of chemical reactions. This is the easiest part of our chapter, and so let's go ahead and get started. The first type of reaction is called synthesis or a combination, so you can use either name, and they both mean the same thing. In general, what's happening here is that you have 2 different reactants that are going to combine to make one product. So when you're identifying the type of reaction, what you're looking for is the basic structure. So our key that we want to look for here is that there's only one product. So here we see there's one product, AB, so that must be a synthesis or combination reaction. An example of that is listed here, where you have 4 golds plus 3 chlorine gases yields 2 gold 3 chlorides. Again, we know that this is synthesis or combination because there is only one product. The second type of reaction is called decomposition, and it's basically the opposite of a synthesis reaction. Here, we're taking one reactant and we're breaking it down into the different products that make it up. So our key here, again, is one reactant that's being broken down. An example of that is when we take 2 potassium chlorates and we break it down to 2 potassium chlorides and 3 oxygen gases. Once again, we're looking for that key that there is only one reactant in the reaction. In a single replacement reaction, which is also called a single displacement reaction, we have one element that's combining with one compound. And what we see here is that the element takes the place of one of the elements in the compound. So we start out with A being the single element, and we end with B being the single element. We start with B and C being combined to form a compound, and we end with A and C being combined to form a compound. Our key here is that on both the reactant and the product side of the reaction, we have one single element plus one compound. Our rule is likes replace likes. This means if our single element is a metal, then it will replace the metal in the compound. If, on the other hand, our single element were a nonmetal, then it would replace the nonmetal in the compound. An example of this is when you combine copper with silver nitrate, and you end up getting silver plus copper 2 nitrate. Because copper was a metal, it replaces silver, which is the metal in the compound. So that's how we end up with copper 2 nitrate as our compound and silver as our single element. Next is our double replacement reaction or double displacement reaction, and it works very similarly to the single replacement reaction. The big difference here is that we have 2 compounds on the reactant side and 2 compounds on the product side. So our general setup is AB plus CD yields AD plus CB. We can see here that A, our metal, is going to switch places with C, the other metal. So our 2 metals switch places or our 2 nonmetals switch places. Just pick one, and again our rule is likes replace likes. So where we start with A combined with B, we end up with A combined with D. We started with C combined with D, and we end up with C combined with B. So pick metals or nonmetals and have them switch places. The tricky part here is you have to remember what the charges were on the ions and then crisscross them to write the correct formula. If you don't remember how to do this, ask Mrs. Benke for some help. An example of this is silver nitrate plus sodium chloride yields silver chloride plus sodium nitrate. We know that this is a double replacement or double displacement reaction because both sides of the reaction contain 2 compounds. Our last type of reaction is a combustion reaction. Combustion reactions are going to be where you see explosions and fires. They usually involve combining a carbon and hydrogen compound with oxygen, and they give off heat, carbon dioxide, and water. In this equation, you see that I have CX plus HY. The reason we have X and Y there is because carbon and hydrogen compounds can come in all different combinations with all different numbers as the subscripts. It doesn't matter what the numbers are, the point is that it's a carbon and hydrogen compound that's combining with oxygen. Our key here is that the products are only carbon dioxide and water. An example of this would be methane combining with oxygen gas to form carbon dioxide and water. For your practice problems, please copy down these skeleton equations on the bottom of your notes page. First, I would like you to balance each chemical equation, and then I would like you to identify them as either synthesis or combination, decomposition, single replacement, double replacement, or combustion. Remember to put your name on your notes and submit them to Mrs. Benke either as a paper copy or on Schoology.